The learning goal for this question is zeros of polynomial. The first part A, is asking to find a polynomial with integer coefficient of degree 5 with zeros that are so and so and so, and multiplicity so and so and so. So zeros are basically 2/5, -5, and -2 and 5. And so the factors, let's see, part A, factors that associate with those is x minus the first one times x minus the second one, which is minus 2 is +2, then x minus the third one, which is -5. The next part is that the multiplicity of the first one is 2, so 2 power 2. Then multiplicity of the second one is 2 power 1, and the third one again 2 power 2. Let's quick check. This is going to be, if I expand it, it's going to be x squared minus 2 times x times 2/5, which is minus 4/5 of x, plus 2/5 to power 2, 4 over 25. So there's the highest degree in here is power 2. Here is power 1. Here again you will get to power 2. And so power 2 times power 1 times power 2 for the highest degree gives me a power 5. So that I'm okay. Now, one other thing that it's asking is to have integer coefficient. I can tell that for some of these, if I start foiling, that 4 over 25 is going to, the 25 in the bottom is going to, in the denominator, is going to show up in some of these factors. Some factors it simplifies a little bit, but overall, for example, if I multiply it by x squared, then multiply it by x over here, is going to show up in the denominator. To get rid of that denominator, I have to multiply it by 25. Part B is asking to find all possible rational roots, zeros of 2x to power 3 minus x minus 1. Notice this is not quadratic, and so I have to really guess the roots or use another method to get to a quadratic equation to solve from there. And so, I mean, at least to find a linear for degrees that are higher, and this one is 1 higher, so I need 1 linear factor before getting to a quadratic. So in here, what I do is I'm looking at the constant, I'm looking at leading coefficient. All the factors of a constant, which in this case is just plus minus 1, give me the numerator of those rational roots if they exist, and all factors of the denominator, which in this case is plus minus 1 and plus minus 2. So I have plus minus 1 in here, so those give me the denominator. So it goes plus minus 2 plus minus 1 over plus minus 1, which you have all the situations that can happen, and you end up with either plus minus 1 for that one and plus minus 1/2 for the other one. That's part B. Then part C is asking you to find the zero that actually works. To do that, I'm going to plug in P of 1, P of 2, P of -1, P of 1/2, P of -1/2. P of 1, if I plug in, I get 2, 1 to power 3, minus 1, minus 1, and this is going to be 0. If I plug in -1, I get -2 minus 2 equal to -4. If I plug in 1/2, I get 2 times 1/2 to power 3 minus 1/2 minus 1, which is 2 times 1/8, which is 1/4, minus 1/2 minus 1, which is basically is going to be minus 1/4 minus 1 minus 5/4. And similarly, -1/2 is going to give me negative 1/4 minus 1/2 minus 1, which is negative 3/4 minus 1, which is negative 7/4. The only one that satisfied the condition was the first one, and that's the answer. So x equal to 1 is the answer. Now the next piece is asking to factor p of x into a linear and irreducible quadratic polynomial with real coefficient using the polynomial division. So I'm going to do a long division in this case. You can, because you're dividing by x minus 1, you can also do synthetic division. So d, I'm going to do the factor related to x equal to 1 is x minus 1, and then I will have x2 x cubed minus x minus 1, and so there 2x squared goes into here, and I get 2x squared times x, 2x cubed. 2x squared times negative 2x squared. And subtract, and you get, this becomes positive, this becomes negative. 2x squared minus x minus 1. This time around, plus 2x goes in there, and I get 2x squared minus 2x. Change the sign, and you will end up with x minus 1, so plus 1 in here, and then subtract to be 0. So now I can tell that p of x is going to be x minus 1 and times 2x squared plus 2x plus 1. And there's denominator 0, so I don't need to put that in. The last piece, let's go to the left a little bit. The last piece is asking to find all the roots. Now that I did the long division, I know x, well, I knew from part C that x equal to 1 is a root. And then that's a real root, so it's still complex, a complex number. And the other one that I need to find is to set the other factor equal to 0. And from there, I get x equal to negative 2 plus minus square root of 4 minus 2 times 4, which is 8, divided by 2 times 2, and that's negative 2 plus minus. This is going to be negative 4 underneath, so square root of 4 is 2, and then times negative 1 divided by 4. I can simplify that to negative 2 over 4 plus minus 2i divided by 4, which is negative 1/2 plus I/2 plus minus I/2. So that's all the solutions that you get in here.